Okay, so let's study about Coulomb's force and electric field. After this video, you should be able to independently solve the problem dealing with Coulomb's law and the force applying to the charged object in the electronic field. So here we go. So the Coulomb's law, of course, we start with the definition of Coulomb's law, and the Coulomb's law basically deal with, like you can imagine, electrostatic interaction between two charged objects. So you can imagine that you have a negatively charged object and a positively charged object, and they are attracting each other. So basically this is all about Coulomb's law, and unfortunately the electrostatic interaction cannot be seeable or not tangible, so it's kind of hard to imagine, but it exists. So again, this is something you have to accept if you have to deal with this problem. Another things, important things is two oppositely charged objects will be attracted, like I wrote over there, like here. But if you have samely charged object, such as plus, both plus, or negative and negative, it's gonna be repelled. So this is almost common sense. When you have the negatively charged one, they're gonna repel each other or positively each other. But this is something I have to make sure with you that you know that, since it is important. The third thing is electric field. Electric field is not seeable or tangible, but it exists, and it works on charged object. So basically, the idea of electrostatic field is you have two planes, and one is positively charged, and the second one is negatively charged. In this type of room, electric field come from positive to negative. So you're gonna have this type of field, which is called electric field. So this is the definition. And when you have some object, let's say this is positively charged, so this is going towards the negatively charged plane, just because positive object is attracted to the negative one, and this is the force that the charged object can feel in the electric field. Now again, there are several equation and units that you have to remember. Now let's go with the second part. So the standard unit for charge is Coulomb. So the standard is important. You used kilogram or meter for standard unit, but when it comes to the charge, the Coulomb is the unit, the standard unit. And again, the unit for electric field can be written as Newton per Coulomb. There are another way to express, but for now, all you have to remember is this one. And this is also kind of complicated equation that you have to remember, but this is something you have to remember. And of course, we are dealing with Newton, so the unit is Newton. And the Coulomb's law can be expressed as K Q1 Q2 divided by R square. So Q1 is the charge of the object 1, and Q2 is the charge of object 2. And this K is something called Coulomb's constant. you most likely don't have to remember this number, since this is just constant. So this number should be provided, but for now I'm gonna write it. So it's 9.897 multiplied by 10 to the negative 9. And the unit is a little also complicated, but Newton meter square per Coulomb second, Coulomb square. Okay, let's talk about the force applied to the charged object in an electric field. And now again we are talking about force here, so the unit is going to be Newton, and the equation it's relatively simple. E multiplied by Q. So Q is the charge of the object, and E is the electric field. And another important equation that you have to know is the electric potential energy in the field, and which can be written as Q E D, and D is the distance, like I'm traveling this distance, which I'm going to talk about in the next class. So for now, just remember that this equation is just needed. Okay, so you learned everything that you need to solve this problem set, so let's do it. So first question is 2 points, meaning very tiny, charged exert 6.75 Newton force on each other. What will the force become if a distance between them is increased by a factor of 3? So this is obviously talking about the force between two charged objects. So what you want to use is Coulomb's law. So Coulomb's law can be written as F equal Coulomb's constant Q1 multiplied by Q2 divided by R2, and this is 6.575 Newton. And here you're gonna increase the distance. Actually, let's say that the new distance is basically you're gonna increase by the factor of 3. So you can write as R new equals to 3R. So let's plug this equation into Coulomb's law. So in this case, F equals to Coulomb's constant Q1, Q2, because these numbers are not changed. It's kind of useful to use all the equation here. And basically you're gonna put R new square. And if you plug this equation into this here, you can also write Coulomb constant Q1, Q2 divided by 3R square. And if you realize, so this part is exactly same as this one. So basically you can plug this value into here. So this is going to be 6.78 divided by 9. And if you do this calculation, you can get 0.75 Newton. So this is going to be the answer for the problem set 1. It's pretty easy, right? And the second one, what are the magnitude of direction of electric field that exert 3.00 multiplied by 10 to the negative 5 Newton up force on negatively charged 1.5 microcoulomb charge. So you have so this is the problem dealing with the electric field. So you always want to use these two plates. And here you have a negatively charged object, negatively 1.5 microcoulomb, and this has the the upward force. And the first thing you have to know is the negatively charged object is gonna be attracted to the positively charged plane. So the two plane is like this. And like I said in the definition, the electronic field is always going from positively charged to negatively charged. So electric field is like this. Okay, so, and let's use the equation. Now, the equation is F equal to E multiplied by Q. And now we know F, which is this one, and we know Q, which is this one. So if you plugged this number into equation, 3 multiplied by 10 to the negative 5 equals to, E is not known, but Q is 1.5 microcoulomb, which is a negative microcoulomb, which is negative 1.5 multiplied by 10 to the negative 6 coulomb. So naturally, the E can be obtained as 3 multiplied by 10 to the negative 5 divided by negative 1.5 multiplied by 10 to the negative 6, and this goes to 20. And again, the unit of the field is Newton per Coulomb, and it's important to make sure that the direction of the field, so this is going to be negative, sorry. It's always important to making sure of the direction. So number one rule is in electric field, the field goes from positive to negative. So the answer is the, if you call this as upward, the direction is gonna be downward, since this is opposite. And this is the magnitude of the electric field. So hope this was pretty understandable. And if you have any question, just give me a comment in the comment section. Okay, hope you learned something. Bye.